Okay, let's have a look at question 8 there. So question 8 is dealing with trigonometry within triangles now. So it says in the diagram below, T is a hook in the ceiling of an art gallery, and then point P, Q, and S and R on the same horizontal plane, okay, and then they give you there that QSR is 90 degrees plus X, QRS is X, QR is 5 units, and then TS equals to SQ. Okay, now 8.1 says prove that QS equals 5 tan X. Okay, so I've drawn out the triangle there that we're dealing with. We're looking for the side QS over here. Okay, so we can see that we have that angle, we have the side opposite it, so for this we can just use sine rule. Okay, so it doesn't matter which way you put it around, if you put sine on top and the size of the opposite side at the bottom, or if you put it on top, the side on top. I prefer putting the side on top, so it's going to be 5 over sine of 90 plus X is going to equal to QS over sine of X. Okay, so it's opposite over opposite. Okay, so now if we look at that, we know that 90 plus X from our identities, sine of 90 plus X equals cos of X. Okay, so therefore we can change this to cos of X, so we have 5 over cos of X equals QS. Now we want QS on its own. Okay, so all we do is we take sine X across. So we're going to get 5 sine X over cos of X equals QS. Therefore we can see that QS equals to 5 tan of X. Okay, sine of X gives you tan. Now 8.2 says prove that the length of QT equals 10 sine X. Okay, so QT, if we look at this triangle over here, we've just found that QS is equal to 5 tan of X. Okay, we know that angles opposite equal sides. Okay, so they've told us that this side and this side is equal, so we know that that is equal to X. So therefore here is going to equal to, let's see, angles of a triangle add up to 180, so therefore we have 180 minus 2x. Okay, so if we now do use sine rule, we have this side, we have all the angles. Okay, you could possibly use, no, you can't use the cos rule, you have to use sine rule. Okay, so let's have a look here. We're going to say QS over sine of X, and then we want QT is then going to equal to QT all over sine of 180 minus 2x. Okay, now if we sort this out here, we're going to get that QS is equal to 5 tan, so then we have 5 tan of X all over sine of X over there. Okay, and then that's still equal to QT all over sine 180 minus 2x. Okay, so now let's have a look at our identities over here. If we have sine 180 minus 2x, okay, so if you look at your cast diagram, here's 180 minus 2x, we're still going to be in this region over here, so we just left with sine of 2x. Okay, so we're then going to have 5, I'm just going to write this out, sine of X over cos of X all over sine of X again. Okay, and then that equals to QT all over sine of 2x. Okay, so let me just go up to the top here. So now we're dealing up here. Okay, so if we now finish this up and we get QT on its own, okay, we're then going to have to sort out this. So let's see, I'm going to expand the whole thing out. 5 sine of X all over cos of X divided by sine of X. Okay, so that's that whole fraction. And then what are we doing? We're multiplying this by sine of 2x, and that's going to equal to QT. Okay, so just writing it all out here, we know that if we divide, we can change this to a multiplication sign, and then this becomes 1 over sine of x, so therefore sine of x and sine of x are going to cancel out, so we're then going to be left with 5 sine 2x all over cos of x equals to qt. Okay, so now that we have that, we can then simplify that sine of 2x can be changed to 2 sine x cos x. Aha, so we have 5 2 sine x cos x all over cos of x. So we can see the two coses are going to cancel out, equals to qt, and therefore we end up with qt equals to 10 sine of x, just like we wanted. Okay, now if we look at the last one there, it says calculate the area of the triangle if TQR equals 70 degrees and x equals to 25. Okay, let me just fix question 8.3 here. I see I made a bit of a mess. Okay, so 8.3 is asking you to calculate the area of this triangle over here. Okay, we know that QT, we've just worked out, it's 10 sine of x, and then we know that QR is 5. Okay, we know that the area of a triangle is half base times our perpendicular height. So I've redrawn this triangle over here. Okay, so I've just rotated it round, so I have QT and R over there. This is 5, that's sine of x. Okay, so they've told us that x equals 25 degrees, and then they've told us that the angle between QT and TR is 70 degrees. Okay, so now what they want, it's on the other side. So this here is 70, okay, and then this here is 5, but this triangle still works the same. So if I draw a perpendicular triangle over here, I'm still going to end up with this line over here being sine of 5 times sine of 70. Okay, that's just working out Pythagoras or using your angles in order to get the length of a side here. Okay, those of you who take physics should know how to break up a line into its x component and a y component. That's just vectors. Okay, but those of you who don't, you can always use Pythagorean theorem to break up into a vertical and into a horizontal component. Okay, so now if we want to calculate the area of this triangle, it's going to be the base. Okay, so it's going to be half my base, which is 10 sine of 25, okay, multiplied by my perpendicular height, which is then going to be this height here converted into the vertical component, which is then just going to give us 5 sine of 70 degrees here. Okay, because if you follow this, then this here becomes 70. Okay, and if you then plug that into your calculator and you sort it all out, you're then going to get an answer of 9.93 units. But remember, they want area, so it must be units squared. Okay, and that's how we go about doing this question. Okay, if you guys are finding these videos helpful, then please leave a thumbs up on the video. It does help me out a lot. If you have any questions, please leave them in the comment section down below. I'll get back to them as soon as I can. If you are enjoying the content, go check out the other past paper questions that I have on their channel. While you're there, consider subscribing to the channel as well. And remember, it's never too late to have an OIC moment.